Welcome, everyone. Thank you all for coming here, and it's a big pleasure for me to be presenting in front of you today. And as you can see, the name of my talk is Lord of the Patch. And for those of you who came here for lots of Lord of the Rings references, memes, and tons of diagrams, it's your day. So congratulations. And fun fact, only today I realized that I made a parallel between Lord of the Rings and my presentation, and we're actually in the cinema. So sit back, relax, and enjoy the presentation. So I would like to start with introducing myself a little. My name is Vladyslav. I work as a security engineer at About You, and my main focus is technical aspects of security. So I do the penetration testing, audits, securing the infrastructure, hardening our applications, and so on and so forth. So yeah, and today I will tell you about one of the things we do inside the team of the security team of About You. Okay, so let's begin. So big data, machine learning, artificial intelligence, and blockchain will not be a part of this presentation. Why? Because I just think that in most of the modern organizations, there is no real practical application of these technologies in security domain. And why? Because I believe that you can protect yourself and your organization from most of the attacks by following really simple rules. And they're actually like so simple that nobody is talking about them nowadays. They're just too boring for the tech world of 2018. And what are those? What are actually these things that you have to follow? And this is actually pretty simple, just recommendations like update your software, use the built-in features of your operating system, like Microsoft Defender, macOS Keychain, firewall, of course, and then use strong and unique passwords. That's very typical, but a very good advice. Nobody follows that, but it's very important. And even if you have those strong and unique passwords and you're like really proud of yourself, yes, I'm using password manager, but the passwords are stored in databases. And databases get what? They get hacked. So to protect yourself from that, you need some sort of other layer of security, which is in this case double-factor authentication. And of course, as a last advice, you should use end-to-end encryption to protect your communications online and be a little bit more private. And I believe that these 5 things on the personal level, like for your personal laptop, can protect you from like 90% of attacks. And on the organizational level, it's a little bit different. The numbers could be, of course, different from that. And there some other things might be added, like intrusion detection, but this is like the core. And I think this is like things that companies should start with. And yeah, please tell me where in these 5 things you see such a complex engineering problem that would require AI or blockchain or machine learning. Maybe in firewalls and intrusion detection systems. But then, as the practice shows, it still generates false positives, and it needs engineers tuning that system all the time, which costs a lot of money. So yeah, and actually, the difference in between implementing all of that for your personal laptop and for organization is that it takes much more time and more effort to do it for the organization. So today we will focus only on one of these things, which is updates and how to do them, how to install these updates on multiple hosts, and so on and so forth. So imagine the situation, you have around 400 hosts running at the same time in your AWS infrastructure or any infrastructure, and a new very nasty vulnerability just got published online, and you have to patch that like everywhere, right now. Not right now, yesterday. So how would you feel? probably you'd feel something like this. And yeah, if you have headache from patching one supercritical vulnerability, then probably, and most likely, you have headache from patching other vulnerabilities, which are not critical, sometimes even like super low severity. So yeah, and this is what I currently oversee in a lot of organizations, even though I haven't worked there, but from reading the news and so on, that patches are most of the time ignored or not given enough attention, so in the end it creates a problem. But why should actually companies and organizations patch those low severity vulnerabilities that are basically like not really likely to happen or not really likely to be used against your infrastructure? And I have only 2 words to explain that. And these 2 words are hot potato. And yeah, I see some confused faces out there, and I was ready for that. So I will explain. Hot potato is an exploit from 2016 that allowed an attacker to escalate his privileges, so increase his privileges on Windows operating system from the lowest to the highest ones. And the main idea was that this attack does not involve some like super big 0-day vulnerability found in Windows. It involved 3 low severity vulnerabilities that were not fixed or patched by Microsoft. They seemed not important to them. And let me quickly go through it on a very high level. So this attack consists of 3 steps. And the first one is to poison the DNS cache of the victim. So basically, the mapping in between IP addresses and domain names on the victim machine is totally controlled by the attacker. So he can say, okay, this IP belongs to this domain name. And of course, the attacker will use that in the second step to trick Windows into believing that there is a proxy on the network and it should use it. And of course, Windows will be like, oh, hey, there is a new proxy. I should forward all the traffic through it. And yeah, this traffic will be then used, this proxy, sorry, will be then used to relay the NTLM credentials. NTLM is an authentication protocol in Windows. Yes, and those credentials will be relayed through that proxy to, in the end, create a system service to run like arbitrary commands by the attacker. So yeah, it may sound complicated. If you're interested, you can go online and read about this attack a bit more. But the main idea is what I mentioned before. All these 3 vulnerabilities, 3 steps, are considered low severity to create, in the end, something that would be considered critical. And we have another example coming from DEF CON this year, where a researcher used 4 different bugs/features. And when I say bugs/features, what I mean is that in real life, it often happens that security people, they come to developers and they say, oh, hey, this has to be fixed. This has a security issue. And developers are like, you know, we actually want it this way. And this is kind of a feature that we have. And we don't think that in a real world there will be a scenario where an attacker can get something from it. So what security people do, they go home, they draw the curtains, fuel up with energy drinks, and start writing exploits. So yeah, this is what the guy did, and I will not go through the attack like very detailed, but basically he used different path normalization and parsing logic errors to pop a shell on a Java system. So yeah, and when I say a critical vulnerability or a non-critical vulnerability, what does it actually even mean and how to classify them? And for that, there is a really good project that is being run by the security community in the world. It's called OWASP Top 10. You probably heard about it. OWASP stands for Open Web Application Security Project, and top 10 is a list of vulnerabilities that are like most critical in the world, and it is sorted by severity. So which ones are the most dangerous? Yeah, and you can see on the first spot there is injection. So what this list doesn't tell you is how likely an attack is to happen on your infrastructure. And it makes sense, because imagine your police department coming to you and, okay, maybe not coming to you, but just saying, 90% of burglaries in your neighborhood did not happen through open windows. But it doesn't mean that you don't have to close your windows, right? Because if a burglar would come, he would just enter through the windows. But when it comes to the choice of investing money and resources into protecting windows or doors first, this is where likelihood comes really handy. And some other people sorted the OWASP top 10 list by the likelihood of the attack. Let's look what happens. As you might notice, what was on the first spot, an injection, it moved to the third spot. And what do we see on the first spot? Using components with known vulnerabilities, or in other words, not patching your damn software. So what kind of lesson can we take from it? And we listen to the professor Farnsworth, and he says that innocent-looking bugs can be really dangerous if they are used in a creative way. And this is what hackers are using actively nowadays. But coming back to the example environment with 400 hosts, like running somewhere, one does not simply patch 400 hosts. Why? Because, yeah, it's really complicated. You have to take a lot of stuff into consideration. And yeah, this is what I want to talk to you about today, and something that we implemented to tackle this problem. And basically, we will address the following questions, like how to protect yourself from these dangerous attacks, then how to automatically deliver the latest patches to your servers, not only the operating system patches like kernel, but also the packages. Then how to keep track of the patching process across all your systems, because in an organization like About You, we have like 50 AWS accounts, and different people are responsible for those, and it gets really messy when you want to like find that account that is not doing patching, and that team, and that person that did not apply patches, and tell him, hey, it's time to do something. And the last one is how to effectively communicate this information to stakeholders. So it's really like clear and visible who needs to do what. And before I start talking about what we did or what you could do in your company, let me tell you a little bit about our setup. So everything runs in AWS with few exceptions, but we just disregard that. And all the applications run on EC2 instances behind autoscaling groups and load balancers. We have Nessus as a vulnerability scanner. It's really popular, widely used. And we have Securitymonkey for scanning AWS for issues. And Securitymonkey is a really nice open source tool developed by Netflix. It basically constantly polls APIs of the Amazon to describe your infrastructure, find issues there, and report them. So it's a really cool tool. So when we started thinking about patch management and vulnerability management, we had like 3 requirements. We wanted it to be automatic, so we don't really need to put a lot of manual work into this process. We wanted to detect the patch differences on every host, and which vulnerabilities are related to which patch difference or version difference, and we wanted clear reporting that teams can work with. And basically, there were 2 possible ways for us to go, either to buy a commercial solution or to go with a hybrid solution. And by hybrid, I mean taking what we had already, so Nessus, Securitymonkey, and like AWS capabilities to satisfy all our demands. And there are really good commercial tools and services that provide all of that, like out of the box. But when we thought about it, we were like, okay, let's think about time to integrate a new solution and time to build on top of what we have. And the time difference, at least in our opinion, was not that high. So we just went for it. And what was another like argument for building by ourselves was that Nessus and SecurityMonkey already satisfied 2 out of 3 of our requirements. So we just wanted, and we just needed to implement the third one. Plus, we had some bonus features, like extended vulnerability scanning with Nessus and AWS infrastructure analysis with SecurityMonkey, which is really nice. So this is where we come to the main part of the presentation, which is Lord of the Patch. It's basically a story of the 3 parts where different technologies come together to deliver a patch to the cloud doom. And yeah, we will go through every part one by one. And the part 1 is the fellowship of the patch. And this one is about how we deliver patches to AWS and to our servers. So it all starts on Tuesdays with Jenkins taking all the Amazon machine images, running the dist update, dist upgrade on them, and then creating a pull request to our source control, because we keep all the infrastructure in CloudFormation templates. So basically, the role of Jenkins is just to create a new image that is patched and then replace the ID of that image in the CloudFormation template. And we have separate staging and production environments, so this is kind of done in 2 steps. Why? Because teams want to like first test the staging environment so that like patches did not break anything. And then this is all like tested for, I don't know, whatever kind of tests they do. And then a pull request is manually created to production. It is accepted, and basically it's done. But there is an issue in all this process. And spoiler, this issue is related to humans. I will tell you why. And it brings us to the second part of the Lord of the Patch, which is the 2 pull requests. And in the process, in the previous slide, you have seen that there are 2 pull requests. And one is created by Jenkins, and it basically happens in like 1 to 2 hours. Actually, I will be honest with you, I don't know the exact time. How long does it take Jenkins to update all those images and create a pull request? Because every time I come on Tuesday to work, the pull requests are already there. So I don't care how long does it take. It basically starts at some point on Tuesday and finishes before I come to work. So it's really nice. But then, when the humans get involved, it takes 2 to 3 weeks to accept that pull request on production. So, like, and with patches coming every week, like, we found teams that were like not patching at all for months and months. So we really needed to tackle that, to tackle this issue. And how we did it, we built a tool that would go through every Jenkins build. And it's all organized in a way that every Jenkins build is associated with AWS account. So it goes through every Jenkins build, and if it's successful, it also checks for the status of the pull request to production, to staging, and reports the status of it. So like, is it merged, is it open, is it denied, whatever. Yeah, when there is no auto-scaling group in the AWS account, the automatic patches are not possible, so we just ignore those. And then it goes further and checks for the pull requests to production and reports on the status of that. And yeah, you see differences in between like these week numbers because we want to know at which like week, at which point the all the accounts are. Yeah, so this is really nice. We just basically have to run the script, and it goes through something like 50 accounts, and it reports this data. Then whenever something is off, we just find a team that is responsible for that and tell them, okay, you have to accept the pull request, and you have to start working on that. So yeah, everything's done automatically. It's really nice. And this brings us, yeah, but actually, these week numbers, what do they tell you? Basically, nothing. Because how do you know which vulnerabilities are there? What are your risks to that particular machine? So this is what part 3 is about, the return of the PatchBot. And yeah, the PatchBot is a system that is built on 3 technologies, like main technologies. One is Nessus, I mentioned it before, SecurityMonkey, and AWS Lambda. Why Lambda? Because we didn't want to maintain any infrastructure. We just wanted something to run somewhere. And if you know how Lambda works, it's basically a place where you put your code, and it executes it, and you pay for time that it executes. So it's really nice. No maintenance involved. I'm really happy about that. So the process of PatchBot, how it works, looks something like this. It's super messy, and we will go like step by step. So let's delete all of that. And in AWS, we have SecurityMonkey. We have 3 Lambda functions responsible for different things. Why 3? Because first of all, Lambda has a time limitation that it can run. And second, like for example, if you need to replace something or fix something, then it's not like one big monolithic system and everything basically crashes. Only something crashes, and we can fix that. And we also maintain state of the lambdas in an S3 bucket. And instead, in the office, we have Nessus that is running there, Jira is hosted there, and Rocket Chat for internal communications. And what the PatchBot does, it first takes the IP addresses from SecurityMonkey. So because SecurityMonkey knows how many instances we have at this particular point of time and what are their IP addresses. So it takes those and gives it to Nessus. Of course, Nessus can scan the whole networks, but or subnetworks. And but subnetworks can be thousands of IP addresses. And if Nessus starts pinging every one of them and checking if it's alive or not, then it takes hours and hours. Like it could take 1 day to scan one subnet. So, but we don't have that problem because we know from SecurityMonkey the IP addresses of all instances. So for speed, we take that. And then the Nessus executes another Lambda, starts like waiting for the Nessus scan to finish. It takes some metadata from SecurityMonkey. Then it gets the report from Nessus. It parses it and puts it into an S3 bucket. It puts it there for, first of all, for history, and second, for another Lambda that we will talk about a bit later. But yeah, it starts at some point, and then this Lambda, which is parse scans, it creates a Jira ticket. So our ops team can go there and start working on the patches. And how does this ticket look like? Something like this. Sorry for all the redacted information, but it had to be done. Who knows, maybe you would go there and try to hack us. So what kind of info we have? We have here is number of issues on number of hosts. We have information like for every account, there is every instance listed with a number of vulnerabilities. So this is for the case when you have this very critical machine and you want to go there and remove all the vulnerabilities, patch everything that is off on that machine, everything that is vulnerable. But what if you want to remove like one unique vulnerability from all your hosts? We also have this info, and it comes in the description of the ticket, and yeah, basically it lists what kind of vulnerability is there, and then it just lists all the instances that are related to that have that vulnerability. And also we create these JSON files for teams that to work with. So what kind of information is in there? It's basically the current version of the package and what it should be. So it gives information to the ops guys what to do to fix it. So it's really nice. And then it also posts some information on Rocket Chat. So because Jira tickets often get lost or people don't care about them. And yeah, it's basically the summary of the Jira ticket, like how many issues and how many hosts, blah, blah, blah. And then another Lambda, which is very interesting, it takes the information from the S3 bucket on all the previous scans that have been there historically, and it accumulates some information and draws plots. What are these plots? We have the plot on the left reports the number of unique vulnerabilities. So we take all the vulnerabilities, put them in a unique list, and put them on the plot. So it gives us information like what is our patching situation or vulnerability situation over time. So how well are we doing over time on our patches? And another plot, it gives us information regarding the number of vulnerabilities across all the hosts. And you can see it's very unstable because the load balancers and autoscaling groups, they create new instances and delete new instances based on the load that we have on the website. So this number can be different, but still gives us some insights regarding this. And yeah, this is basically how it works. And for what we discussed, the Jenkins thing, like with the pull requests, so the part 1 of the load of the patch, it gives us possibility to deliver patches automatically, so nobody has to take a painkiller every time we want to patch something. With the spreadsheet that we saw, we have the visibility, so how teams respond to the automatic patching process. And with the last thing, the PatchBot, we are able to communicate that information properly to people that are responsible for that, and they can really work with this information. And yeah, of course, it's not perfect. There are issues and challenges that are yet to be overcome. Like first is the Nessus API gets end of life. So with a standard Nessus license, we will not be able to trigger the scans, for example, with the Nessus automatically. So we are currently in the process of looking for another vulnerability scanner. Also, we are in the process of figuring out how to deal with the static nodes, or so those that are not created by autoscaling groups, that are created by hand, which is the worst, or with some sort of automation like Ansible. And of course, we want to prettify all the code, write unit tests, and in the end, open source it, because yeah, I believe, and we believe, that it's a really nice tool that companies can take as a reference if they want to build something similar. So yeah, this is what we have planned, and the last thing I would like to leave you with today is don't let hackers point to your mistakes, and start acting now, so that you don't have to deliver those patches yesterday. So this is everything that I have for you today. One last thing, we are looking for some colleagues. So if you're interested in doing something like that, you can put the resume on my desktop, or you can contact our recruiters, or just put it on their desktop. Depends on what you prefer. And yeah, now it's time for questions. So thank you very much for listening. Okay, yep, over there. Yeah, so I will repeat the question. The question is there a gap between what we see from the inside and what hackers see from the outside? And the answer is we have a bug bounty program running. So yes, we get it. Of course, not everything is included in the scope of it, but we are working on extending the scope more and more. Other question? Yes. Yes. Yeah, so the question is, I've shown that it can take 2 to 3 weeks to merge the pull request to production, and whether it means that if there is a critical vulnerability our systems are vulnerable for 2 to 3 weeks? And the answer is no. Of course, when there is something critical or 0-day, we act immediately and we tell our ops team, like, okay, you have to do this and you have to do this now. Yes, another question? Okay, the question is there a reason to use Jenkins and CloudFormation instead of other tools? And actually, I don't know the exact reason, but our ops and DevOps people, they use Jenkins for a lot of automation and CloudFormation for the infrastructure as a code. So this is how it works, and we just took this process and made it like kind of didn't want to change anything. Anything else? Okay, cool. Thank you very much. I hope you have pleasant talks coming later. And yeah, if you want to ask some more questions or talk about security, just find me somewhere in the hall. So thank you very much.